All right, you guys. So I actually really kind of like this lesson. And, in the past, I've taught this differently. Sometimes I start the integrals unit with this lesson, Riemann sums. Okay, before I even teach what an integral is or anything, sometimes I end it with that. So let's see if it kind of like makes sense to you, okay? Okay, here's the idea, right? It's like, if I can't integrate it, if it's just some random, like let's say this is like a stock value or something like that, and I want to figure out what the area under the curve is, okay? Like I'm trying to figure out this area, but it's not like straight lines and it's not geometric figures, and I don't have a like way to calculate it. We can approximate it by making little areas, all right? So we can approximate it with areas of rectangles. It's called what's called a Riemann sum. All right, so check this out. So if I want to approximate the integral from 0 to 10 by adding the area of the 5 rectangles, okay? Now, all right. Let's talk about, yeah, there we go. We got like left, right, middle. Okay, there are 3 types of Riemann sums, you guys. We have a left-hand sum. They call it like a left hand. We have a right-hand sum, and we have a midpoint sum, okay? Okay, now I'm just gonna color on this graph really quick so you guys can see it, all right? You don't write this down yet, but just so you can kind of get an idea real quick, okay? Okay, so let's say I have 5 rectangles, all right? And my rectangles are going from, they're each a width of 2, 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, okay? Okay, let's do a right-hand sum first. A right-hand sum says, okay, between 0 and 2, I go to the one on the right, which would be 2, and I go to the height of it, and I make a rectangle, okay? And let me just like cover this in so you guys can see that. Boom, okay? And then 4, I go to 4 because it's on the right, and I color that in. All right, and I have that rectangle. And then I go to 6, okay, and I color that in. And then I go to 8, and I make that rectangle, and I color that in. And then I go to 10, and I make that rectangle, and I color that in. I can look at this and say, hey, do I think this is like an overestimation or an underestimation too? Remember what it actually is. So compare that. Let's see what color I can use. Compare that to like this, right? So compare my purple to my blue right here, okay? And if I said like which of those has like more area, well, it's kind of interesting because you've got like a little bit up here, which is maybe canceling out that, and a little bit here, which is maybe canceling out that, or whatever. Okay? All right. That is called a, what did I just say? Right-hand sum. Now let's say I'm going to do a left-hand sum. Now let me start with these rectangles over here. So between 8 and 10, I'd use the rectangle at 8, and I'd use that one. Between 8 and 6, I'd use the height at 6. Between 6 and 4, I'd use the height at 4. Between 2 and 4, I'd use the height at 2. And between 0 and 2, I'd use the height at 0. And so this would look like this. So this is the same, I guess. And then all that. Okay. And then all that, and then like nothing over there. So clearly that is a little bit too less, like that's too much of an underestimation, right? So those are your left and your right. Okay. Oops. Okay, now let me show you what a midpoint one would do. All right, let's talk about what a midpoint one would do. So basically, erase all this. Let's say I'm splitting it up into 5 rectangles. Okay, again, so it's like 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. Well, instead of saying, well, I'll do a left with the 0 or I'll do a right with the 2, you do a midpoint sum, which is the one right in between. And so I'd make that. And then between 2 and 4, the midpoint is 3. So that would be the height. Between 4 and 6, that's the midpoint. So that would be the height. Like I'm going to actually erase There we go. Okay. And it's like the midpoint between 6 and 8, the midpoint is here. So that's the height. Between 8 and 10, the midpoint is here. So that's the height. We kind of like doing midpoint rectangles because with midpoint rectangles, you kind of are getting like a little bit of the up and a little bit of the down. So of the three, midpoint usually approximates it the best. That's a midpoint Riemann-Sum. Okay? Okay, left, right, midpoint. So let's actually look at some examples now. Let's go and look at this one. Okay? So measure the 5 rectangles shown. All right, so the midpoint. So what we're doing is we're saying, okay, the first rectangle has a base of 2, right? Because it goes from 0 to 2. So it has a base of 2 and the height. Now what I have to do right here is I have to find the height at 1. And the height at 1, you guys, is just 2. But another way of saying the height of 1 is saying the y value at 1. And the y value at 1 is like f of 1. Okay, does that make sense? So then it's the y value at 1. The base of the next rectangle is 2, but now I got to get the height at 3. Well, another way of saying what's the height at 3, it's the y value at 3. My next rectangle has a base of 2, and then I have a height at 5, so the y value at 5. My next rectangle has a base of 2, and then I need to get the y value at 7, so f of 7. And then my last rectangle has a base of 2, and it has a y value at whatever the y value at 9 is, okay? Now, one thing I want to tell you is if you have equal bases, see how they're all a base of 2? And it's like kind of annoying to go base times height, base times height, base times height. So each of these I have like, this is my base, this is my height. Does it make sense that I could just put the 2 out front? It's like I'm factoring it out, right? And then just get all the heights right there. So the height at 1 is 2. The height at 3 was 5. The height at 5 was 3. The height at 7 was 1. The height at 9 is 3. And instead of doing base times height each time, let me just add these up. That's like 14. And so the area of all of these rectangles is 28, okay? That's the area of those rectangles. So I'm going to approximate it under the curve as 28, all right? Now, you guys, how could I get a better approximation? Well, instead of 5 rectangles, what if I made 10 rectangles? And each one I did a midpoint. So that's that rectangle, that's that rectangle, that's that rectangle, the midpoint, that's that rectangle. I would actually get a little bit more accurate, okay? Let's say I did 20 rectangles. Let's say I did 40 rectangles. Let's say I did 1,000 rectangles. I'm going to get pretty accurate. The more rectangles I make right here, the more I make. And the more accurate it gets, like that, okay? Okay, let's approximate this. Is this the same graph? I think it is the same graph. I think these are telling me what numbers it goes to. I don't really need that. Let's approximate this with left. Draw rectangles on the figure. Okay, so my left, and again, I'm doing 5. Oh, I want to show you guys something. Okay, if I'm going 0 to 10 using 5, you guys know it's like a width of 2, but there's this thing that that's going to come up later, and it's b minus a over n, and that gives you the width of each rectangle, because it's like total of 10 divided by 5, each one has to be 2. So the width of each rectangle is 2. So we're using really easy numbers right now, but just kind of keep that in mind. Okay. My base is 2. This is for my left. My base is 2. And then I'm just going to do a bunch of heights. Now, for the left-hand sum, I'm going to start with the height at 0 for that one. Then I'm going to start with the height at 2. That's my next one. Between 4 and 6, I'm going to pick the height at 4. I drew that wrong. That was a midpoint. Hold on. Okay, so I go to 4, and I draw a height of 4. And then a height of 6, that's going to go right there. So I'm going to draw a height of 6. And then at 8, I'm going to draw a height at 8. Okay? All right, because 8's on the left. And I'm not using 10 because I was using a left-hand sum. So those are my rectangles. Okay, and then you can read it off here. I guess you can look at the table, but so 0, the height is 0, 2, the height is 4, 4, the height is 4, 6, the height is 2, and 8, the height is 2. 12. I'm going to keep making that so big. Okay, so this has an area of 24. See how that's like significantly, well, not significantly, but I mean, that's less than 28. That's an underestimation, okay? That's probably a pretty good underestimation, all right? And so we can get like midpoint sum, left sum, whatever, okay? Okay, here's a new example. This one did not give us a graph. This didn't give us a graph. Now, the first thing I want you to notice, we have 4 subdivisions, but you guys, these are not all the same width. Do you see that? So if you think about like, okay, I'm making a rectangle right here. What would the base of the rectangle be? Well, that one would have a base of 2. And then I'm making a rectangle here. What would the base of that rectangle be? Well, 2 to 5 is 3. And then I'm having a base of a rectangle here. 5 to 9 is 4. And I'm having a base of a rectangle here. 9 to 10 is 1. So they have different widths, okay? These are the widths. And they're different, right? Okay, now, if I'm using a right-hand sum, on the rectangle between 0 and 2, I'm going to pick the height is going to be the height at 2, which is 8, because it's a right-hand sum. And between 2 and 5, I'm going to pick the height of 5, which is 2, because it's a right-hand sum. So I'm picking these numbers on the right. For this one, I'm picking -1, and for this one, I'm picking a height of 0. Okay, so you don't have to really draw it either, you guys. You kind of just go like this. Here's how I'll do it. So for a right-hand Riemann sum. Okay, so I look here, and I go, okay, the base is 2. The height is the y value on the right, because it's a right-hand sum, right? And then I'm looking at this one. The base is 3, and the height is the y value on the right. And then I'm looking at this one. The base is 4. And the height is the y value on the right, okay? And then I'm looking at this last one. The base is 1, and the height is the y value on the right. So it's 16, 6, -4, 0. So that is, what, 18? And that's my Riemann sum, okay? So that's like pretty straightforward, all right? Okay, cool. We have a graph here. It always helps if you have a little bit of a graph. So square root of x squared plus 10, midpoint sum, 3 equal subdivisions. So first of all, the width of my rectangles is going to be 6 minus 0, 3 subdivisions. So every 2, I'm going to put, well, hold on a sec. Let me just mark it down here. So 0 to 2, 2 to 4, 4 to 6. Okay? Now, since it's a midpoint sum, so the width of my rectangles, actually, let me just do it like this. Midpoint. All right, because they're equal subdivisions, I can just say that the base is 2, and I need to have some heights here. Well, the heights of my rectangles are going to be at the height of 1, because that's the midpoint, the height of 3, and the height of 5. Okay, now you guys, I would be approximating that if I was trying to do it, you know. What is the actual height at 1, 3, and 5? Well, this is the graph of the square root of x squared plus 10. So the actual height at 1 is the square root of 1 squared plus 10, so it's square root 11. The actual height at 3 is the square root of 3 squared plus 10, so it's square root 19. And then the actual height of 5 is the square root of 5 squared plus 10, which is the square root of 35. That's my sum. You know, and I could put that on a calculator and I could figure out the decimal value, and then I could see like how close it was to it, right? So it might be interesting to take a quick second and do that. I'll pause it so that you guys aren't waiting for me to type this in. Okay, cool. So you guys, I went out and typed this in. So this is what I got with Riemann sums, right? I got 2 and then square root 11, square root 19, square root 35. And so this is telling me that it's about 27.183 is the approximation. Let's see what the actual integral is, right? That's just the approximation, 27.183. Well, if I put this in here, Let me go ahead and graph it. I'll just hit zoom 6 so we can see it. Okay, you guys can see that there. All right. And then if I calculate the integral from 0 and I push enter to 6, look at it's 27.330. That's what that is. 27.330. Okay. What did I get over here? 27.183. Hey, that was a pretty crummy approximation and it was still within 2/10. So that's not bad, you know? That was like a decent approximation, I guess. All right. Approximate 2 to the x minus 8 dx from -5 to 10. 5 right-hand rectangles whose widths are determined by the intervals separating the following x values. Ugh. Okay. -10 to 4. So I've got that rectangle. To 0 to 2 to 3 to 5. Okay. 5 rectangles. There we go. All right. Okay, so here we go. I'm doing a right-hand rule. So the base of the first rectangle, all right, so if you guys check this out, the base of the first rectangle from -10 to -4, that's what, 6? And I have to do a right-hand sum, so the height of the one on the right. So I'm going to do f of -4. I'm going to set this up and then I'll do it. The next one has a base from -4 to 0. That has a base of 4. And then a height of the one on the right, which is 0. Okay, cool. The next one has a base of 2 and a height of the one on the right. The next one has a base of 1 and the height of the one on the right. And then the last one has a base of 2 and a height of the one on the right. Okay, so those are my 5 rectangles. So how do I figure that out? Now, I'm not just going to try to like look on here because those are all approximate. But again, what is this equation right here? Well, this is the equation 2 to the x minus 8. And so what I'm going to do is plug in -4, 0, 2, 3, and 5 into that, okay? So this will look like this. All right, you guys think about this real quick. What's 2 to the -4? Is that's like 1/16 minus 8, so that's the height of that one. If I plug in 0, what's 2 to the 0 minus 8? That's 1 minus 8, that's -7. If I plug in 2, it's 2 squared minus 8, and 4 minus 8 is -4. If I plug in 3, 2 to the 3rd minus 8, 8 minus 8 is 0. And if I plug in 5, 2 to the 5th minus 8, that's 32 minus 8 is 24. Okay, so I have, let's go backwards here. I have 48, that's 0, -8, -28, and whatever that is. Okay, if it's free response, I'm done already. If it's multiple choice, geez, I would, have to do fractions. I don't want to do that right now. So I'm going to go, what's 6 times 1/16 minus 8, and that's -47.625. Add all these up, and I get -35.625. So why is this coming up as a negative? Well, if we look at what we're approximating right here, guys, from here, okay, it's all of this, and this. So there's just more below. That's what we're approximating. So there's more below than above. That's why we get a negative. All right? Okay. Now, the next rule. All right. So let's go back to this graph that I was looking at up here. Let's wait for and just watch this part, okay? Just check this out. So it's like, okay, left-hand rule, it's kind of lame. Doesn't really approximate it great. Right-hand rule, kind of lame. Doesn't approximate it great. Okay, then we said, okay, midpoint rule. And I was like, ooh, I like that one. Because it approximates it a little bit better because we go to the height here. And so it's like sum over, sum under. We go to the height here, right? We go to the height here, the height here, and the height here. And that's midpoint rule. And that's like, oh, cool. That approximates it kind of nice, right? Okay, now we're going to make trapezoids. Now, you guys, trapezoids, we picture them like this. These are going to be trapezoids on their side. The definition of a trapezoid from geometry is two parallel bases, the other two not parallel. So, for example, that's a trapezoid, right? Well, I'm going to take that and turn it on its side, and that's a trapezoid. All right, so we're going to do these like up and down trapezoids. So let me show you on here. Get it bigger so you can see it. Okay, so from 0 to 2, what the trapezoid would look like is you put it at 0, you put it at 2, and you draw a trapezoid in between them. Okay, 2 to 4, what the trapezoid would look like. Wow, it's just a square. That's lame. All right, 4 to 6. Here's my trapezoid. So you draw this. There's 4. There's 6. That's a trapezoid. Okay. 6 to 8, my trapezoid's just a rectangle, but whatever. And then 8 to 10, it goes here to here. That's my trapezoid. Now look at how nicely that actually, like specifically look at this one over here. Okay. That really nicely approximates that because it, you know, doesn't do too much under or too much over. It just kind of slants it, you know? So these trapezoids are better. I mean, this one's like almost perfect. I like drew it like almost right on that line, right? So if you look at that trapezoid, you know, if I were to take that away, look at that. That's pretty dang close, okay? So trapezoids are actually going to be the best approximations. So let's do some trapezoids here. All right. Okay. 0 to 10. We got 5 different regions here. Now, here's the area of a trapezoid. Let's write it down in case you all don't remember this. A trapezoid is 1/2 the height and then the sum of the bases, okay? So, for example, say we had, these are the type of trapezoids we're used to seeing. Make this one a little bit like that, right? And this is like base 1, base 2, and the height of the trapezoid was like this, okay? And so it's basically like we're averaging the bases and making this height here, because what you're really doing is you're taking this and you're like, oh gosh, let's see if I can explain this. You're kind of like averaging so that and that go away and it makes a rectangle, you know? So it's 1/2 the sum of the bases and the height. Now, these are sideways trapezoids, all right? And so it's like, let me look at number 2. Number 1's weird because it's just a triangle. Look at number 2 real quick. That's a base, that's a base, that's the height. Does that make sense? So that's just think of it, these are B's. Think of it as a trapezoid on its side, okay? Now, because these are perpendicular, the heights are always going to be along here, all right? So remember, it's 1/2 the height, and the height of a trapezoid, when it's on its side, is really the width of it, you know? It's like that width right there. And then we're adding together the two bases, which in this case would be like F2 plus F4. Okay, because those are the two bases. Hopefully that makes sense. All right. So let's see. Let's come over here and let's go. All right. Got to add the 5 trapezoids. So let me do it like this. Trapezoid 1. Now, if you want to say, Mitchell, that's a triangle. I ain't doing a trapezoid. I'm going to do a triangle. Go right ahead. But it basically goes like this. It's 1/2. The height of the trapezoid is like the base, so that's 2. And then it's f of 0 plus f of 2, averaged out. All right? Now, I know from looking at this that it's f of 0 is 0, f of 2 is 4. 1/2 times 2 times that just gives me 4 for this trapezoid right here. All right? Which, again, if you had just done a triangle, we're getting something 1/2 base times height. Okay? All right. Trapezoid 2. 1/2 the base of this, which is the height of the trapezoid, which is 2. And then this is f of 2 plus f of 4. So it's the height at 2, which is 4. So let's see. Plus, and then it's the height at 4, which is 3. So 1/2 times 2, so that's 7. So that's that trapezoid. right? And we just go through and we do all these trapezoids. So trapezoid 3 is 1/2. The base, wait, did I do? These are different width bases. Dang it, I thought they were giving us the same width base. Let's go back for a minute. Trapezoid 2, this actually looks like it's going right up to the 5, huh? This one, it's not at 4. That's at 5. That's a 6. That's a 8. That's a 10. Okay. Gosh dang it. All right, so trapezoid 2, everything else is the same. It just happens to have a base of 3. Which does not cancel out so nicely. That's annoying. So 7, that's 21/2. Okay. Trapezoid 3, that has a base of 1. And then I have to do f of 5, f of 6, because those are the heights on either side. Okay, f of 5, that went up to 3 and 2. So that gave me like 5/2, right? You guys get the idea. I think I can like speed this part up a little bit now. So let's just go with trapezoid 4, which honestly is just a rectangle. But we can still use the trapezoid formula because it's 1/2. The base of that is 2. And then the sum of the heights, that's at 2 plus 2. Okay, so that's 4. And then we're going to go last but not least to trap 5, which is 1/2. The base is 2. And then I got to do the sum of the height, like the average of the heights. Well, f of 8 is 2. F of 10 is 5. So that gives me 10. So then I'm just going to go back and basically add all these up. So I have 4, 21/2, 5/2, 4, and 10. Let's see. Putting those two together, that's 26/2, that's 13. 23, 4, 5, 6, 7, 8, 9, 30, 31. That's 31 with trapezoids. All right. Whew. Okay, let's do one more trapezoid here. Use trapezoid 4 equal subdivisions. Now, because it's 4 equal subdivisions, I'm be kind of smart here. I can go a little bit faster. Because I know that each trapezoid is going to be 1/2 base, and then the sum of the heights on either side. These are sideways trapezoids, right? So it's going to be 1/2. The base of each of these, you guys, is 20. Or, sorry, is 10. 10 to 20, 20 to 30, 30 to 40, 40 to 50. The base of each of these is 10. And then for the heights, so I've got different trapezoids. Now, I want you guys to see this. The first trapezoid, I'm going to do f of 10, f of 20. That's trapezoid 1, right? The second trapezoid, I'm going to do f of 20, f of 30. That's trapezoid 2. Then the next trapezoid, I'm going to do the heights f of 30, f of 40. And then my next trapezoid, I'm going to do f of 40, f of 50. So I want to show you guys, a lot of times, the way you'll see this written up in like an answer key or something like that is, it's like, okay, so I have f of 10. Just write that in here. And then guess what? I have f of 20 twice. So why do I have that twice? Oh, in fact, actually, let me write it down here. Okay, so I have an f of 10. And then I have 2 of those. Well, because one goes with that trapezoid, one goes with that trapezoid. And then I have f of 30 twice. And then I have f of 40 twice. Get down there. Okay, 2 f of 40. And then I have f of 50 once. Okay, does that make sense? They gave me values over here. So I had 1 f of 10. I had 2 f of 20s. I had 2 f of 30s. I had 2 f of 40s. And I had 1 f of 50. That's okay for a free response. That's fine. I'm done. On a multiple choice, you could type, and if it's on the calculator or something, you could just type this in. Let me go ahead and put that on my calculator. So it's 1/2 times 10. That's just going to be 5, right? And then I just go 1.8. 2 times 2. 2 times 2.5, 2 times 3.5, 2 times 2. Oh no, sorry, the last one is just 2.2. 2.2. Boom, I got 100. Cool. Okay, so there you go. That's using left, right, and midpoint and trapezoid to approximate if we can't find the integral.